Hey, one last example here. We've got the absolute value of x minus 5 equals x squared minus 8x plus 15. And if you remember back, the first thing we want to do here, the first thing is always identify it as a piecewise function. Okay? Sorry, let me just redo that. That's a real mess there. Okay? X minus 5. Okay? Expressed as a piecewise function. It can be positive. It can also be negative. Okay? It's positive, which is greater than or equal to 0 if x is greater than or equal to 5, and it's negative if x is less than 5. Okay? So remember, this is going to be what determines the answers that we get once we solve this, if those answers are actually true or not, because we have a certain domain that x values can only be in when given this absolute value. Okay, so let's go ahead and solve each of these now. So we get positive x minus 5 equals x squared minus 8x plus 15, and we get negative x minus 5 equals x squared minus 8x plus 15. Okay. Alright, so let's go ahead and solve this now. Okay, so I'm going to subtract next, add 5 to each side, and I'll get 0 equals x squared minus 9x plus 20. On this side, I'm going to do this all in one step here. Okay, I'm going to have to add an x and add a 5 to each side. Okay, now if a 0 equals x squared minus 7x plus 10. Okay, so now I have to factor each of these. Okay, two numbers that add together give me negative 9, multiply together to give me positive 20. Well, those two numbers are x minus 5 and x minus 4. Okay, so my two answers here are x equals 5, x equals 4. And over here, they have to add together to give you negative 7, multiply to give you positive 10, so x minus 5, x minus 2. So I'm left with x equals 5 and x equals 2. Okay, but remember, I have to go back and look at these domains. Okay, this domain comes here, this domain comes here. Okay, so x equals 5. That is in my domain up here. Okay, x equals 5. X is greater than or equal to 5. Okay, that one's good. X equals 4. X is greater than or equal to 5. 4 is less than 5. That one does not work. Okay. Second part of the question, x is greater than, or sorry, x is equal to 5. X is equal to 5. This is x is less than 5. That one's gone. X equals 2. Okay, x is less than 5. 2 is less than 5. Okay, that's good. So when it comes to our solution, x can equal 5 or 2. Okay, so that's our answer to this, or two possible solutions to this absolute value equation. Okay, the key part is to remember, I don't think you guys will have any problem with solving. Okay, the important part is to check back in your domains from your piecewise function. You have to remember to do that. Okay, so just a quick review, really quick. Remember, you can solve absolute value equations by graphing. And we know how to do that now. You just graph the left side, you graph the right side, and where the two graphs intersect is your solution to the absolute value. Okay. To solve an absolute value equation algebraically, you have to remember that there's two separate parts, there's two separate cases. There's the positive and the negative. And you have to check your answers to make sure they are in your domain and reject any that aren't. Okay. You can verify your roots by subbing back into the equation. As always, we always know that. You can check an answer to an equation by subbing back in. Okay, any absolute value equation in the form the absolute value of f of x equals a, where a is less than 0. Okay, so a is negative. So we saw the example of the absolute value of f of x equaled -7 or something like that. There was no solution. Okay, no solution to that because an absolute value has to be greater than or equal to 0. So just some key ideas to remember. Okay, as per usual, there is your assignment right there. We'll work on that tomorrow and the next day. We'll see how things go. But we'll see you in class tomorrow.